All right. So here's the review for the topic H exam. Okay, it is 10 questions worth, it should be worth 50 points. It says 10 points here on the top, but it should be 50. Okay, first question says the problem below refers to right triangle ABC where C is 90 degrees. So when you have a right triangle, all right, you have an L and that's your 90-degree angle. You have a single C, 90 degrees. So it says little b is 8 and big C is 10. So if this is C, like capital C, this is going to be a little c. And then it doesn't really matter. We can call this A and this angle B. So this is angle A, opposite to angle A is like a little a. And then opposite to B down here is little b. So angle A, side A, they're opposites. Angle B and side B, those are opposites. So the question once again says you're trying to solve for A, and we know B and C is 8 and 10. So B equals 8 and C equals 10. So we're trying to solve for A, the missing piece here. So A squared plus B squared equals C squared. That's the Pythagorean theorem. This one works out perfectly because C is the hypotenuse. So it's always going to be this side squared plus that side squared always equals your hypotenuse squared. So I'm going to go ahead and say A squared because I don't know what A squared is. But B equals to 8, so plus 8 squared. And that's going to equal C squared, which is 10 squared. So A squared stays the same, but 8 times 8 is 64. 10 times 10 is 100. Solving for A squared, I'm going to subtract the 64 to both sides. And A squared is going to equal 100 minus 64, which is 36. And so I'm going to square root both sides so that A squared becomes just A. That's what the square root does to a squared term. And then 36 is 6 squared. So 36, the square root of 36 is just going to be 6. Okay. And that is a Pythagorean triple. And if you're not quite sure, you struggle with this stuff still, there's a Pythagorean theorem calculator. I'll make sure I post it for you guys so you guys know where it's at and how to get that. A, we don't know what A is, but B is 8 and C was 10. Hit calculate, and it says A is equal to 6 right here, which confirms what we did there. That is a 6, 8, 10 triangle, Pythagorean.
You have a question about where you got the 64.
All right, that was from B squared, and B equals 8, and 8 times 8 is 64.
Yeah, she figured it out.
10 times 10 is... Okay.
Perfect.
Yeah. So that was the first topic in topic H, was Pythagorean theorem. So let's do this next one. Now this next one's going to be a special triangle. So if you remember from way back, a whole 2 weeks ago. Okay, so if you go back 2 weeks ago, what's going on? Why can't, there we go. 2 weeks ago to week 9, that was when we first started topic H, topic H1. You can probably click right on the topic H1, should have it on there, these special triangles, which it does not. Awesome. The overview and to-do list from week 9 did have the notes from class. All right. So we went over some special triangles. This one here looks like the one on the right. This is a 45, 45, 90. Whoops. Triangle. Looks just like this one here. Now, yours might look a little bit different. Yours might look like one of those patterns. Okay, remember those two patterns we went over. This pattern says, with a 45, 45, 90 triangle, I recognize it's got a 45 degree and 90 degree angle. It forces this one to be 45 every single time. Every time. So for this one, okay, following this example, it says whatever's on this side is up here also. And whatever's up here at the hypotenuse is going to be this number times the square root of 2. It's a pattern. It's literally just a pattern to follow. Okay. So for mine, I would say 11 square root of 2. And it goes backwards too, so I'm not sure what yours might look like, but if they give you something like 11 square root of 2, well, then your side length would just be 11. Okay. Like you kind of remove the square root to get to the side lengths. Okay, so that's question number 2 for your test. Let's take a look now at question 3, which appears to be a 30, 60, 90 triangle. Okay. So the 30, 60, 90 triangle looks a lot like the stuff we did here, the special triangles. Okay, theirs is laid down in a different way. Okay, so what you have to identify, right, this is the one you really got to think of: baby shark, mama shark, daddy shark. Okay, baby shark is the small side. So in this case, you see 50 is a small side, or in this case, 60 is the small side. The smallest side is opposite the smallest angle. So 30-degree angle makes 60. In this case, a 30-degree angle creates the 50. The 30-degree angle creates the x. So small angle, small side. Medium angle, so 60 is a little bit bigger than 30. Medium angle, like the mama shark, 60 goes to x times the square root of 3. So it's a little bit bigger than x, whatever that number is. And then the hypotenuse, which is opposite the 90-degree angle, 30, 60, 90, becomes the biggest piece, the daddy shark piece. Okay. So in this case, they gave us from A to C, and they want us to know that piece there. So this is 60. This is like the mama shark piece here. So that makes us 30, which is the baby shark piece. So this piece then is always 2 times bigger, whatever the baby shark is. If baby shark is 50, then the daddy shark's 100. Okay, if baby shark was 60, the daddy shark would be 120. It's always 2 times the size as the smallest piece. So if this is 6, I'm going to double 6 to get 12. That would be it. Okay. It always has, from the smallest piece to largest piece is always double. And then the middle piece is always this times the square root of 3, which is like a square root of 3 is close to like 1.7. So that's like, so 6 times 1.7 is a little bit less than 6 times 2. It's just kind of this little relationship here. Okay. All right. So yours is probably going to be something similar. They're probably going to give you a small piece and look for the middle piece or the big piece or something similar. Yeah. Keep this up for a moment. Okay. So it's the first 3 questions what your test will look like. Let's take a look at number 4. Question 4 gives us to solve for x in the following triangle. Figure is not drawn to scale. So this is a Pythagorean theorem type question. Okay, you can just plug in the numbers here. We have 6 and we have 9. Okay, I'm not going to hit calculate. I'm going to do it by hand first. Let's see what we get. This one appears to be a radical. I believe we're going to get a radical when we simplify this. Let's see what we get. So a squared plus b squared equals c squared. Let's go ahead and let's put it in the right order. This would be a over there. That would be b down there. So 9 squared plus 6 squared. When you do this, the order doesn't matter because you're squaring numbers and adding them together. You'll get the same answer regardless of which order that's in, but that's going to be, we'll call it x squared. Why not? Because it says x. So 9 squared is 81. 6 squared is 36. Adding those together, we get 117. Okay. So I'm going to square root both sides, and 117 is not on that list of squares. So remember I gave you guys a list of squares. Was that? Yeah, it's also on the week 9. Okay, so I look at 117, and 117 is not on this list. It goes from 100 to 121. So it's close to 121, but it's not. So 117 is a square root, is some decimal between 10 and 11. It's probably like 10.8 or something like that. I don't know, but it's close to 11. So, right, if I do 10.8 square it, so times 10.8, it should be close to 117. 116.6. Okay, close, super close. So if I calculate this, I get 3 times the square root of 13, which is simplified version of square root of 117. 117 does divide by 9 if you divide this out, because 1 plus 1 plus 7 equals 9. It's that weird trick. So there are ways to simplify that. We're not going to simplify that right now. Let's see, that would be 3. All right, so this, would be 3 square root of 13 would be the simplified version. But you can just put square root of 117 from the work I believe I've seen so far on the test for topic H3. they'll give you the right answer even if you put square root of 117 and you don't simplify it. If we had time in class, we'd go over the simplifying process, but we just don't have all the time. So I'm going to tell you guys, if you have trouble with this kind of stuff, please use a calculator like this. If you know how to use the calculator, that's fine. You've picked up the basics of Pythagorean theorem, and we're good. We'll be okay. We'll be all right. So that's that one. It's probably going to give you 2 sides, and you got to solve for it. If they give you the hypotenuse, make sure that you're doing the work correctly. Okay. The reason why I squared these and added them together was because they're the 2 side lengths, not the hypotenuse. Okay. All right. So question 5 looks similar, but it's got some algebra. How did I not? How did that one slip in there? Skip number 5. Skip number 5. It's going to have an x squared term in there, and we're just not going to do x squared stuff like that. I know you're like, well, we just did an x squared. This one's going to be like a whole lot different, though. This one's going to have a quadratic term and a linear term. It's going to be disgusting. It's not that bad. It's just skip it. So your test is only 9 questions. Woo! Awesome. Okay. We'll skip number 5. That's a little bit shorter test for you guys. Okay, so question number 6, this is where it gets back into the sine, cosine, tangent, and then cosecant, secant, and cotangent. So that's the work we did last week, which is pretty this is really complex stuff. So if you had some struggles last week, don't stress. This is something that you can talk about for a whole entire semester or a whole entire school year and still not learn everything about it. Okay, there's a lot to learn about trigonometry, the study of triangles. So that would look like if we went to week 10, and that overview and to-do list should have some notes on this stuff if you forgot what we kind of did last time. Let's take a look at Wednesday's meeting. Okay, right triangle, terminal side, initial side, all that kind of stuff. So when you see things like this, sine and cosine, they're just fractions. Like you see sines to fractions. So it says here that theta terminates in Q2. Okay, that's quadrant 2. What that means is there's quadrant 1, and then it goes in a circle and counterclockwise. So it goes 1, 2, 3, and then 4 is always down here. So it terminates in quartile 2. That means you'll have some dot over here, and it makes a right triangle like that. Okay. So it says sine is 12 over 13. Whenever you draw a triangle on here, the angle in like a regular standard position always kind of goes in this little corner. So it says sine is 12 over 13. So here's the easiest way of how to do that, right? Sine of any angle is the opposite divided by the hypotenuse. Okay, that's at SOHCAHTOA. Sine is so, cosine is that ka, and then tangent was OA. So whenever you see something like sine, you should be thinking of the fraction opposite divided by hypotenuse. Opposite divided by hypotenuse. So when I see 12 over 13, this is like the opposite, and that's like the hypotenuse. So the opposite is 12, and the hypotenuse is 13. So that leaves us here with the adjacent side. This is the adjacent side. Whoops. That's the adjacent side. The adjacent side means that it's next to the angle, but it's not the hypotenuse, right? The angle is always created with the adjacent side and the hypotenuse. Opposite just means it's the one way on the other side. So if they want to know the cosine is the adjacent over hypotenuse. So we can use Pythagorean theorem to figure this out. Or if you remember your Pythagorean triples, that would be like a 5, 12, 13 triangle. So if you don't know what one of the pieces are, we can put 12 and 13 because we have a hypotenuse. This would be like piece C. Calculate this bad boy, and it says 5. That's a 5, 12, 13 Pythagorean triple. Okay, 5, 12, 13. So if they want the cosine, the adjacent is 5, and the hypotenuse would be 13. So if the sine is 12 over 13, the cosine would be 5 over 13. Oh, wait a minute. Let's go back to our notes. There's a reason why they said quartile 2, because it might be negative, actually. Remember that kind of weird stuff? There's negatives for this stuff. I believe the negatives we went over on Friday. Yeah. Okay, so the quartile 2, sine's positive. So sine was positive. However, cosine and tangent were negative. So I'm going to put a negative there. Okay. Okay. Because, yes, that would have been going up 12. They say you go with left 5 to get the point there. How cool is that? Lovely. Beautiful. So sine, cosine, tangent, I understand, is a very difficult topic. And if you don't pick it up right away, it can be very frustrating and difficult. Okay. So we're here to help you guys out and work through all these patterns and fun stuff. So once again, this is being recorded. I will post this so you guys will have access to this during the test. It's question 7. Let theta be the angle in standard position whose terminal side contains a given point, then compute cosine and sine. So they're not telling you, but that's going to be over here in quadrant 3. Okay, it says negative 12 and negative 5. So it looks almost like this, at least for my stuff, it's like the same kind of question, right? I see a negative 5 and negative 12. Wait a minute. I'm going backwards. It goes backwards 12, right? Went backwards 12 this way and down 5 that way, right? So that would be down here in quadrant 3. Quadrant 3 says tangent's positive, but the sine and cosine are the negatives. So I'm thinking right now, before I forget, sine and cosine need to be negatives. This is a 5, 12 on the sides. So this has to be 13. Has to be 13. How do I know that? Pythagorean triple. 5, 12. Always make 13 when you square them and add them together, and then square root the result. C equals 13 every single time. 5, 12, 13 triangle. Okay, so from this angle here, the opposite is negative 5. Okay, so this is the angle. So the opposite is negative 5. The adjacent would be at negative 12. And the radius, the hypotenuse, would be 13. Okay, that one's always going to be positive. No, it's kind of weird. Sine theta would be negative 5 over 13, because remember, it's going to be opposite divided by hypotenuse, right? Sine is opposite divided by hypotenuse, so negative 5 over 13. And the cosine would be negative 12 over 13. Because that is the adjacent divided by hypotenuse. Okay. Pretty complex stuff. Okay, so just make sure, be advised of how they're kind of setting these things up. Okay, this was, yeah. That's the additional notes that we did on Friday. Okay, taking a look at question number 8. Indicate the two quadrants theta could terminate in if cosine theta is negative 3 over 5. All they want you to do is look at negative 3 over 5 being cosine, and cosine is positive and 1. So here's our options, right? Either 1 2, 3, or 4? Which one is it? Well, we know it's not 1 because see how it's negative? We know it's positive in 1. So we know it's not 1. And 2, cosine's negative. Check. 3, cosine's negative. Check. And then cosine is positive in 4, it says. Okay. So it says 2 and 3. It says to not use Roman numerals, use regular numbers. So we'll say 2 and 3. And right here, we're like a little note here, x is like your cosine and y is like your sine. So it kind of makes sense. If x is your cosine, where is the x negative? The x is negative on this side and this side. Right? This is your graph. This is like the negative side of x's. It's positive on this side for x's. Okay. And the opposite, so for your x's, yeah. But for your y values, right? For your y values, it's positive up here. So that's why in quadrant 1 and 2, sine's positive. And then it's negative down there. So that's when you're kind of going like, if it says something about cosine, that means your x values. It says something about your y values or your sine values, it's your y values. So where is x positive? It's positive in the first and fourth quadrant. It's negative in the second and third quadrant. And this one, where is the y value? Positive, negative. Y value would be your sines. Your sine would be 1 and 2. But no bueno down there. Okay, 2 more questions, and then we'll call it for the general review of the test, and then we'll open it up to study hall afterwards and help you guys out, get caught up. Question 9, indicate the quadrant or quadrants in which the terminal side of theta must lie in order that cosine is positive and tangent is negative. Ooh. So let's go back through once again with 1, 2, 3, and 4. It says tangent's negative. Well, in quadrant 1, everything's positive, so we know it's not 1. We just discussed that cosine is positive only in 1 and 4, so that leaves us with just 4. Let's double check. In quadrant 4 is cosine positive and tangent negative, and 4 cosine's positive, tangent's negative, so it would be in quadrant 4. So to do these kind of questions, like questions 8 and 9, I would write out 1, 2, 3, and 4, and then just go through each one. 1's always positive. Okay, 1 is always positive. Okay, this is a beast. They want us to do all 6 trigonometric functions given the cotangent theta is negative 1/2 and terminates in quartile 4. So off the bat, we already know this one's going to be this. That's good. So we've got something over here in quadrant 4. Oh, remember the 5th of November. Tangent and cotangent are just upside down of each other. So here's a cool one you can do. If this is negative 1/2, tangent then would be negative 2/1. What? Oh, man. All right. So once again, we have sine of an angle equals opposite over hypotenuse. If we see the cosecant of an angle, it's just this upside down. Okay. When they give us or ask for the cosine of an angle, that is the adjacent piece divided by the hypotenuse, and its related one is the secant, and the secant is just this upside down. And then it says the tangent and cotangent. So tangent is O over A, opposite divided by adjacent, and cotangent is just this upside down. So adjacent over opposite. So that's why when I saw a tangent, they gave us this number. That number is just this one, but upside down. That's it. That's all you got to do for that one. Now we got to figure out the rest of them. So real quick, they already told us quadrant 4. They already told us something about quadrant 4. Wherever that dot is, I don't know. But starts here in the middle and creates some sort of triangle that will look like that. Okay, I'm not quite sure what the pieces look like, but yeah. Okay, so it says the tangent, which we just figured out, which is -2/1. Okay, this would be opposite over hypotenuse. They gave us the opposite over adjacent. They gave us the cotangent, which is adjacent over opposite. Sorry. So I like just referring back to tangent, not cotangent. I went ahead, like I said, took this and I flipped it upside down to get the regular tangent, not the cotangent. And I'm going to think if this is here, this is the adjacent, this is the opposite, that's the hypotenuse. Remember, opposite's always away from the angle. So if they say the opposite is basically, it doesn't have to be, but it's just a cool little thing. We can kind of figure this out by doing this, by saying if opposite is here on top, it's going to be a -2. It's going to go down, right, 2. And the adjacent, they say, is 1. Because in quadrant 4, think about it, it's like a +1 this way, but it goes down 2 that way. That's why it's -2. So we got to figure out the hypotenuse. That is the a squared plus b squared equals c squared, where a equals, let's say, 1, b, let's just call it 2. So that's 1 plus 4 equals c squared. 1 times 1 is 1. 2 times 2 is 4. C times c is still c squared. So I get for a hypotenuse the square root of 5. And if you're not sure on how to do that kind of stuff, again, let's do a Pythagorean theorem calculator. Let's say one piece is 1, other piece is 2. 1 squared plus 2 squared and square root that. You're going to get the square root of 5, which they estimate to be about 2.23. Okay. So square root of 5, we got it right. Cool. All right, so what that means here, if basically now it's like Mad Libs, like just filling in the blank. It's like paint by numbers. If for all these problems here, for opposite, we're going to use a -2. For adjacent, we're going to use a +1. And for the hypotenuse, we're going to use a positive square root of 5. So now it's just filling it in for all these pieces. That's all we're doing now. Once we figured out the hypotenuse, we can figure everything else out now. So sine is opposite over hypotenuse. So -2 divided by the square root of 5. Cosine is adjacent over hypotenuse. So 1 over square root of 5. Secant, well, that's secant is hypotenuse over adjacent. So radical 5 over 1. And then lastly, cosecant, which is hypotenuse over opposite. So radical 5 over -2. I'll put the negative out front. Okay, so over here, it says in quadrant 4, they told us quadrant 4, you should have a positive cosine. So positive cosine, positive secant, because they're like the same. And then everything else should be negative, sine and tangent. So negative, 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 negative. Cool. I would type all those numbers in, and I would call it a day. Oh, cosecant, once again, was hypotenuse over opposite. It kind of frustrates me because usually we write it like this, where it goes sine, cosine, tangent, cosecant, secant, cotangent. But they did some weird thing where it went like this. It went sine, cosine, tangent, cotangent, secant, cosecant. It's kind of a weird order, but I usually go this way than that way. That's how I usually see it. So I'm going to go ahead. I'm going to stop the video. That has been the presentation. So that will be your video to review the test. All right.